boiling points are the temperature that particles in a substance have enough heat energy to be able to turn into a gas. And so if we have a liquid, right, that's what we're starting with, and we add heat to it, the particles are going to start speeding up and spreading out until they turn into a gas. And so understanding that heat causes particles to speed up and spread out helps us to understand why things appear to be boiling as they turn into a gas, because they literally look like they're moving faster. So we start out with a liquid, right, and it turns into a gas. And technically, this process, scientifically, is called vaporization. This is when we add heat to a liquid, the liquid vaporizes. Then, when we remove heat from a gas, then that process is called condensation. So if we look here, this water is boiling. But when I hold this lid over, you can see that when the vapor hits the cooler lid, it condenses. Both of these processes, vaporization and condensation, happen at the boiling point temperature for a substance. So it's not that there's a vaporization point and there's a condensation point. They both happen at the same temperature. When we add heat, we can see the temperature increases and increases. And when we look in here, it looks like it's boiling because those gas particles at the bottom of this water are jumping up into the air. But then if we look very carefully, the temperature once we hit boiling point is not getting any hotter. So once a substance hits its boiling point, once a liquid hits its boiling point, it will not get any hotter. It will vaporize into a gas and the gas can get hotter. And when we remove the heat, then the temperature starts to decrease and it's still a liquid. So different substances have different boiling points because it takes a different amount of heat to get the particles moving fast enough to vaporize. So hydrogen is negative 253. Water is 0 degrees Celsius. And iron's boiling point, yes, you can boil iron, is 2861 degrees Celsius. So these boiling points, they basically are the reason that we see things as solid, liquids, and gases. We consider hydrogen to be a gas because at our environment, like on Earth, we range somewhere from about negative 80 degrees Celsius to about 45 degrees Celsius are kind of our highs and lows. Negative 253 is colder than any temperature we would see here on our planet naturally, and so we consider hydrogen a gas because it's basically already boiled. Water has a boiling point above 100 degrees Celsius, and so most of the time here on Earth we see it as a liquid. And then iron, right, has a really high boiling point, and so we see it as a solid because it almost never boils on our planet. So boiling points help us to choose the right substance for an application. Like flax oil has a boiling point of 225 degrees Fahrenheit, and corn oil has a boiling point of 450 degrees Fahrenheit. So if we wanted to pick an oil to fry food in at like 375, we're not going to pick flax oil because flax oil would boil off and then the oil would be gone. And we need the oil to keep our food cooking. And so the corn oil tends to be a more common oil that we fry food in because it has a higher boiling point, and so it stays liquid oil at the temperatures we need it to be working at. It also helps us to store and handle substances properly. So butane has a really low boiling point, below what we would consider 0. So it vaporizes at low temperatures and it's extremely flammable, so we have to be very careful how we store it. Hexane, on the other hand, has a boiling point that's above what our normal temperatures are on the planet. And so it's a liquid all of the time, but it is combustible. It just isn't wildly flammable because it has a higher vaporization point, which then that's how things burn, is the vapors react with the oxygen. Diesel has a much higher boiling point, so it's a much more stable substance. So we don't even have to be as careful with the way that we store diesel fuel as we do hexane. But understand these boiling points, right, helps us to know how we can store and use substances so that we can be safe around them.